The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Okay, so I'm going to work through problem number 7 for the midterm exam 1, physics 2020. And this particular problem says John Force drove his funny car 0.25 miles when starting from rest. His speed at the end of the quarter mile was 375 miles per hour. Assuming that he experienced constant acceleration for the entire trip, what was the magnitude of the acceleration in meters per second squared? Alright, so I want to again say that we're going to be referring to the formula review sheet for this particular midterm, exam 1. And so it might be to your advantage to have this handy so you can follow along. So we're going to try to interpret the problem statement, and in doing that, in the first part of the statement it says he drove his car 0.25 miles, and so we know that the distance that he traveled is going to be 0.25 miles. We also know that he's traveling at a speed of 375 miles per hour, so his final velocity, because his speed at the end of the quarter mile so his final velocity was 375 miles per hour, and we're trying to find the acceleration. One other important piece of information that we can pull from the problem statement is that we're supposed to assume that he experienced constant acceleration. That means throughout his entire trip, he's going to be accelerating at the same acceleration because it's constant. Alright, and that's important because if we look at our formula sheet, we can look for the workhorse equations for constant acceleration. And if we look at these particular equations, we have 4 that we can choose from. The ones to the left-hand side of the box, they both have t in the equation, which represents time. In this particular problem, we're not given any information about time, so they're probably not going to be useful equations for us. Likewise, this bottom one where you have x is equal to x sub 0 plus v sub 0 t plus 1/2 a t squared, again, we're not given any information about time, so that we probably shouldn't use that equation. The only equation that we can potentially use is this one, where we have the acceleration is equal to your final velocity squared minus your initial velocity squared, and that's divided by 2 times the final distance minus your initial distance. Okay? And this is actually the equation that we want to use. And we know that since he's starting from rest, okay, that our initial velocity is equal to 0 because he's starting from rest. So this is 0, and we know that our initial point, our initial displacement is 0. He's starting out from a single point, so that's going to be, we define that as point 0, so this initial displacement is 0. So then this equation just reduces to the velocity squared over 2 times your displacement, and we can substitute in just the numbers now, and we're trying to find, so velocity is 375 miles per hour, and the displacement is 2 times 0.25 miles, okay? And this is actually squared. Okay, that's important. All right? And so we know that this miles is going to cancel out with one of those miles, so we're just left with miles in the numerator. Okay? But we need to basically cancel out the miles because we want meters per second squared. And so we can use our conversions from the formula sheet, and we know that there are 1,610, so in 1 mile, there's 1,610 meters, so that will cancel that out. And we know that there are, in 1 hour, there's 3,600 seconds. So this hours is going to cancel out with this hours. And so we're left with, we actually going to need to do that twice. We need to actually square this term. And the reason why we need to square this term is, remember, we had a squared here, so that means we're going to have an hour squared here. So we need to get rid of an hour squared, and we need a second squared, so we want to square that term. And so whenever we work this out, we get 34.9 meters per second squared, which is the answer.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.